Welcome to 5.5 double angle identities. We're going to take a look at example 1. Given that sine theta equals 8/17 and cosine theta is less than 0, find the values of sine of 2 theta, cosine of 2 theta, and tangent of 2 theta. We will start with sine of 2 theta. First, let's write the identity for sine of 2 theta. Since sine of 2a is 2 sine a cosine a, we have sine of 2 theta is 2 sine theta cosine theta. So notice we have information about just theta alone, whereas we're asked about the trig functions of a different angle, which is 2 theta. We already are told that sine theta is 8/17, so now we need to find cosine theta. So we're told that sine is positive, but cosine is negative. So we have to figure out what quadrant theta is in. So sine is positive and cosine is negative in quadrant 2. But what I like to be very clear about, this picture that I draw here, this is for theta, not 2 theta. So since we have sine of theta is 8/17 and that's y over r, we could put in our y value and our r value as 8 and 17 respectively. And now we can go ahead and calculate our x using Pythagorean identity. Subtracting the 64 from both sides, we get x squared equals 225, which is a perfect square. When we do the square root of both sides, we get x is plus or minus 15. Since we are in the second quadrant, we know that the x value must be negative. So we get negative 15. Now we can figure out that cosine of theta equals negative 15 over 17. Remember, you are more than welcome to just use sine squared theta plus cosine squared theta equals 1 to calculate the cosine of theta as well. Now we multiply straight across. If you prefer, you can write 2 over 1. We will get a negative. And 2 times 8 times 15 gives us 240 on top, and 17 times 17 is 289. Thus, the sine of 2 theta is negative 240 over 289. Now let's move on to find the cosine of 2 theta. Since we have the sine of 2 theta, technically speaking, we can use the Pythagorean identity with these values here, where we'd get this squared plus this squared equals 1. I will go ahead and still calculate using one of these identities. Now, at this time, because we have both sine theta and cosine theta, really any of these options are totally acceptable. However, since we were only given sine theta, I will go ahead and prioritize the formula that only has a sine in it. So that's the last one here. So let's go ahead and use that double angle identity that cosine of 2 theta is 1 minus 2 sine squared theta. So we get 1 minus 2. Sine is 8/17, and we have to square that. So order of operations requires us to square the 8/17 first, where you just square the 8 and you square the 17. Next, we need to multiply. If we want, we can write it as 2 over 1 and multiply straight across. Now we get 1 minus 128 over 289. Now we need a common denominator to subtract. So I will write 1 as 289 over 289. We subtract the numerators, the denominator stays the same, so we get cosine of 2 theta is 161 over 289. Now if we wanted to just examine 2 theta, so we have the sine of 2 theta is negative. Sine is negative, but we found that the cosine of 2 theta is positive. So now, what quadrant would we be in if we had a negative sine and a positive cosine? And that ends up actually being in quadrant 4. So we know now that 2 theta is in quadrant 4. Now that we have the sine of 2 theta and the cosine of 2 theta, the best way to find the tangent of 2 theta is simply to take the sine and divide it by the cosine, since we know that tangent of an angle is sine of that angle divided by cosine of that angle. However, just to practice using the double angle identity for tangent, I will go ahead and do that. So this would be the way that you would do it if we didn't already know sine of 2 theta or cosine of 2 theta. So tangent of 2 theta is 2 tangent theta over 1 minus tangent squared theta. Now, since we have our triangle here, we can see that tangent of theta is y over x, or negative 8/15. So we'll replace tangent theta with negative 8/15 in the numerator and the denominator. On the top, we will multiply straight across. On the bottom, we will square 8/15. Now let's write the 1 as 225 over 225 to be able to subtract. So in the denominator, we end up with 161 over 225. Now that we have a fraction divided by a fraction, we will flip the denominator and multiply. So 15 goes into 225 15 times, since that's where the 225 came from, was 15 squared. And now we can multiply straight across to get negative 240 over 161. So the tangent of 2 theta is negative 240 over 161. Let's check that using tangent of 2 theta equals sine of 2 theta over cosine of 2 theta. Now it's really important to notice that all of these angles have to be the same. So we got the sine of 2 theta was negative 240 over 289, and we found the cosine of 2 theta was 161 over 289. Notice the 289s will cancel, and we will get our final answer of negative 240 over 161, which checks out. So please know that you are always welcome to do any which way. If I were doing this on my own and I already found sine of 2 theta and cosine of 2 theta, I would definitely use this method to calculate tangent of 2 theta. However, if I was just given this information and asked to find tangent of 2 theta, I would just do this calculation here. And then we can also verify, because we had decided that our 2 theta is in quadrant 4, and notice the tangent is negative as we had expected. Example 2. Find the values of the 6 trigonometric functions of theta given that cosine of 2 theta equals negative 12/13 and that theta is in between 180 degrees and 270 degrees. The main thing to notice is that the information given about the cosine of 2 theta is pertaining to 2 theta, not to theta. One very common mistake here is to divide both sides by 2. However, this cosine of 2 theta is a very complicated expression. In fact, it could be rewritten in any one of these ways. None of them is just saying 2 cosine A. Here is a situation where we could divide by 2, because this is just saying 2 times the cosine of theta. So the 2 is just being multiplied by this quantity right here. You almost want to think of a cosine of theta as its own variable, and the cosine of 2 theta as its own variable. So in this situation, we can divide both sides by 2 because the 2 is outside of the function, and so therefore the multiplication can cancel out with the division. So here we would get cosine theta equals 1/2. However, this is different. This is the cosine of 2 theta. So this is one expression here that can't be messed with. Now we need to somehow relate this cosine of 2 theta with a function of theta alone. And that's where our double angle identities come in. This is a situation where we would not want to use the original because it has a sine of A and a cosine of A. So really, either one of these choices is a viable option. So I'm going to go ahead and just write down the cosine of 2 theta formula. So cosine of 2 theta, and I'll choose the middle one, the one with 2 cosine squared A minus 1. So cosine of 2 theta equals 2 cosine squared theta minus 1. So now I need to figure out, where does this negative 12/13 fit in? Pause if you'd like. Well, since it's telling me that cosine of 2 theta is negative 12/13, I can replace cosine of 2 theta with negative 12/13. Now I am able to solve for cosine of theta. First, I add 1 to both sides, or I add 13/13. Now I get 1/13 equals 2 cosine squared theta. Next, I will divide both sides by 2 or multiply by a half, since dividing by 2 is the same as multiplying by the reciprocal. Now I'm ready to do the square root of both sides. Don't forget the plus or minus. Now we could utilize the fact that we know regular theta is in between 180 degrees and 270 degrees. So the theta is in between 180 and 270, so that's going to be in quadrant 3. Therefore, our cosine will be negative. Let's first square root the top and the bottom, and then we can also rationalize by multiplying top and bottom by rad 26. Therefore, I found cosine theta equals negative rad 26 over 26. Now that I have one functional value of regular theta, I can go ahead and draw a picture of theta and find all of the other trig functional values. We know theta is in quadrant 3. Now, we could either use these values, or we could just use the negative 1 and rad 26. And I'm going to use these smaller values. Otherwise, when we go to do Pythagorean theorem, this gets very cumbersome. You would still get the right answer using these values for x and r. Similarly, we could go and do the Pythagorean identities using cosine squared plus sine squared equals 1. So again, I'm going to use cosine theta equals negative 1 over rad 26 so that my numbers are smaller when I go to find y. So I solve for y, going y squared plus 1 squared equals rad 26 squared. So here the square and the square root cancel out. So I get y squared plus 1 equals 26. Subtract 1 from both sides, and y squared will be 25. Therefore, y is plus or minus 5, and since I'm in the third quadrant, my y will be negative 5. Now I can find the sign by finding the y over r, or negative 5 over rad 26, rationalizing to get negative 5 rad 26 over 26. Tangent is y over x, or negative 5 over negative 1, or just positive 5. Now, to find cosecant of theta, I will flip sine, but I'm going to go ahead and flip this before I rationalize so I don't have to rationalize again. So I get negative rad 26 over 5. Again, I will flip the negative 1 over rad 26, or just negative rad 26. And flipping the 5 gives me 1/5. Given one trig value for 2 theta, we first had to use a double angle identity to find a trig value of just theta alone. Once we have one trig value for theta alone, we could either do the Pythagorean identities, or we could go ahead and draw a picture for theta and get our x, y, and r and be able to get all 6 trig values. I hope you enjoyed this video. See you next time.